Let's do some problem solving in partial differentiation. Let's say f of x comma y equal to tan inverse of x by y. Now what we have to do is verify that dou square f by dou square dou x dou y is equal to dou square f by dou y dou x. Okay, so now we know we have to differentiate it twice. Remember, we have to do it with respect to x and then we have to do it with respect to y. So dou f by dou x is equal to, now what? First we have to do for tan inverse. Now what's the differentiation of tan inverse? It's 1 plus x square. So here basically x is x by y. So it will be x by y square times. Now we have to do it for this. So that will be 1 by y, which is equal to, now let's simplify this. How do we simplify this? 1 by, let's take it as 1 plus x square by y square. So now we take LCM. So this becomes y square plus x square by y square. Now which means that this y square can be taken up times 1 by y. And this y and one of this y gets cancelled. So which is y by y square plus x square. Now let's do it with respect to y. Now here y is constant. So again 1 by 1 plus x by y square times, now here remember x will be treated as a constant. So x times, now differentiation of 1 by y. Now 1 by y can be looked at as y to the power of minus 1. So when we differentiate it, what will happen? Minus 1 by y square, which is equal to 1 by y square will come up and here it will become y square plus x square times minus, we can bring it to the front, x by y square. So this y square gets cancelled and we are left with x by y square plus x square, and don't forget the minus. So first partial derivation we have done. Now we have to do it the second time. Dou square f by dou y dou x. So here what are we doing? We are basically doing, so dou f by dou x we have already done. That we are going to differentiate with respect to y. So here we will treat x as a constant. Okay, so this would be what? We square the denominator, y square plus x square the whole square. Then the denominator, when we bring it up, remains as it is, y square plus x square. And then we differentiate the numerator, y. Since we are differentiating with respect to y, it is 1 minus. Now what? Now we keep the numerator as it is and differentiate the denominator. So differentiating the denominator, that is y square plus x square, will make it what? Make it 2y. So now let's simplify this. Y square plus x square minus 2y square by y square plus x square the whole square. This is equal to x square minus y square by y square plus x square the whole square. Okay, exactly similar to that. The only thing is we differentiate dou by dou x with respect to dou f by dou y with respect to x. Let's look at that. That is minus x by x square plus y square. So y square plus x square the whole square, y square plus x square as it is. Now we are differentiating with respect to x. So since it is minus x, it will be minus 1 minus, then minus x remains as it is, and differentiating the denominator. The denominator is y square plus x square. So here y is, we are doing it with respect to x, so it becomes 2x. And now it's just a question of simplifying it. Say minus y square minus x square plus x, not x, it is going to be 2x square by y square plus x square the whole square, and this would be x square minus y square by y square plus x square the whole square. Now if you notice, this and this, they are both equal, so therefore dou square f by dou y dou x is equal to dou square f by dou x dou y. Okay, let's look at the next one. F of x comma y is equal to x to the power of y plus y to the power of x. Again, show that dou square f by dou x dou y is equal to dou square f by dou y dou x dou f by dou x. Now here what happens? Y x to the power of y minus 1 plus, now y to the power of x would be what? Here it, of course it was, y was constant, so we could apply this, but here, okay, how do we take care of this? Y to the power of x can be written as e to the power of log of y to the power of x, which can be written as x log y. Yes. Now when we differentiate this, let's say this is a equal to, so it is still a equal to, but here dA by dx. So here when we do that, what happens? E to the power of x log y, and differentiating x log y gives us log y. Now e to the power of x log y can be written as log y to the power of x, log y. Yes, and this can be, this e and log can again be cancelled, so we end up with y to the power of x log y. dA by dx is going to be yx log y. So based on that, here y to the power of x would be, differentiate, after differentiating it will become y to the power of x log y. Dou f by dou y is equal to what? Same thing in the other direction. Here x will be as constant, so x to the power of y log x plus x y to the power of x minus 1. Now dou square f by, we are going to differentiate dou x with respect to dou y. So dou f by dou x we are going to differentiate with respect to y. So here you have to take it slowly. Y to the power of x to the power of y minus 1 log of x. This is based on what we derived here. Y to the power of y, x to the power of y minus 1. We are going to apply this rule, y to the power of x log y. And we get this plus, remember, it's a product rule. So x to the power of y minus 1, and when we differentiate y it becomes 1 plus y to the power of x 1 by y plus xy x minus 1 log y, again based on this. So this and this is based on this. Now if you notice, we can group them into two terms each. Okay, so x to the power of y minus 1. So we take out that common, that is x to the power of y minus 1, and we are left with 1 plus y log x. So this and this have commonality of x to the power of y minus 1. Now what about the other two? Y to the power of x minus 1. Now here, if you notice, 1 by y can be written as y to the power of minus 1. So, which means it can be rewritten as x minus 1. So y to the power of x minus 1, 1 plus x log y. So this is as far as differentiating dou f by dou x with respect to y. Now we have to do it the other way around. Differentiate dou f by dou y with respect to x, dou f, this one. So here, what is going to be constant? We are going to treat y as constant. X to the power of y, 1 by x, plus y x, y minus 1 log x, plus x y, x minus 1 log y, plus y x minus 1. This, again, you have to do it carefully. Okay, now this x can be taken up, so this becomes x to the power of minus 1. So which means this can be written as y minus 1, x to the power of y minus 1. X to the power of y minus 1 is common. Oh, why did I remove it? Y minus 1. So 1 plus y log x, plus again y to the power of x minus 1 is common. So it becomes x log y plus 1. And again, if you notice that x to the power of y by 1, y minus 1, x to the power of y minus 1, 1 plus y log x by log x, 1 plus x log y, 1 plus x log y, y. So this and this both are equal. So we have shown that dou square f dou y dou x is equal to dou square f dou x dou y. Let's look at slightly different type of problem. Now here what's happening is we have z is equal to 1 minus 2xy plus y square to the power of minus 1 by 2. Remember, it could have been square root of 1 minus 2xy plus y square. Same. And now show that x dou z by dou x minus y times dou z by dou y is equal to y square z cube. Again, just keep doing it. You will arrive. Don't make algebra mistakes. Now here we require what? We require to calculate these two and then multiply respectively with x and y and simplify to see whether we arrive at y square z cube. So dou z by dou x. So here y is going to be treated as constant. So this itself is a constant. This is a constant. So we have to only take care of minus 2xy. Now first we have to take care of the exponent. So 1 minus 2xy remains as it is. Y square to the power of minus half minus 1. And then we have to differentiate the expression within the bracket. So 1 becomes 0, y square becomes 0. So we are left with minus 2xy. Now when we differentiate minus 2xy, we are left with minus 2y because we are differentiating with respect to x. Okay, so this becomes what? Let's simplify. Minus half times 1 minus 2xy plus y square. This becomes minus 3 by 2 minus 2y. Now, a little tricky thing is we can write this as minus 1 by 2. Yes, can we write it like this? 1 minus 2xy plus y square cube to the power of minus 1 by 2. Which means we can, this is nothing but z. So, z cube minus 2y. This is multiplication. So, this is multiplication. So, which means this becomes plus 2y. 2 gets cancelled. So, we are left with yz cube. See, if you miss one bracket, right, I missed it. Once you miss a bracket or even a positive sign for that matter, your calculations will go wrong. Now, d dou z by dou y. Now, let's do this. Same thing. Again, very carefully. Minus half 1 minus 2xy plus y square minus half minus 1. And now we are doing it with respect to y. So what do we get? Minus 2x from this plus 2y. Now same argument. This will become minus 3 by 2. Okay, let's do it step by step. Plus y square minus 3 by 2. This can be written as cube to the power of 1 by 2, or to be more precise, just to avoid any confusion, this should be minus 1 by 2 and this should be cube. This is z and the whole thing becomes z cube. Similarly here, this should actually go up. So this is minus half the whole cube. 2 common, y minus x. So 2 gets cancelled. And we are left with minus z cube y minus x. Take the negative sign inside. What happens? X minus y z cube. Okay. Now, what do we have to show? We have to show that when we multiply x and y respectively, we get y square z cube. X times dou z by dou x minus y times dou z by dou y is equal to y square z cube. Y square z cube. Let's do this. X times, and this is what? Yz cube. Yz cube minus y times, and this is x minus y z cube. We are looking at LHS. So now what happens? XYZ cube minus XYZ cube plus y square z cube. Yes, distributive property. These two gets cancelled out and we are left with y square z cube, which is nothing but the RHS. Okay, so as you notice, there are a lot of places where we can make a mistake. Brackets are very important. Otherwise, what should have been multiplication becomes addition or subtraction. So be careful. Most of the mistakes in calculus is either you don't remember some formula or some theorem, but mostly related to algebra and arithmetic, not to forget that. So I think that's enough for today. Bye for now.